Hi, welcome to the Seismic Retrofitters channel.
Hi, I'm Jeremiah Perez with GeoGrout.
And we're in front of one of our projects in San Francisco. We discovered that it's pretty sandy soil underneath the building and determined that it's best to, because the building is settling slowly, we determined it's best to get some grout injected under the old brick footing to help stabilize the building and mitigate any further settling. So Jeremiah, can you explain kind of what we're doing here?
Here we are following the outside of this building, your footing, your foundation, and we're injecting some holes every 2 feet at different depths, right? Correct? They're different depths according to the plan.
Right.
So basically, 18, like a foot off center from the wall, we'll inject our first point, and then every 2 feet down the whole row from there, we'll inject at different depths. We'll inject our grout balls. Basically, it's a certain amount of gallons accumulates a certain like a ball.
So like a sphere of grout.
A sphere of grout.
So what it does is it solidifies the sand, kind of turns it into almost like a hard
sandstone.
Right. It's a pretty incredible process. And what kind of mix are you using right now?
It's a 2 sack per 100 gallons mix, and it's really good when you're working against sand like how we are now.
So depending on what kind of soil you
exactly.
customize the mix.
Exactly.
So for the sand, is this when you're like near the bay where it's wet, where you're into liquefaction where it's wet, and they talk about the grout actually displaces the water.
Yes, it does actually. The water will start coming up to the top.
So what you're injecting displaces the water and then solidifies, hardens.
Exactly.
So it's a really neat process. So great. Well, I really appreciate it. Thanks.
Thank you.
The building's slowly shifted, and so what we've done is we're coming in here. We're going to inject underneath the old footing, and we're going to go ahead and this grout is going to solidify, harden the sand underneath the building. It's really helpful because it'll stop the settling. And it'll also, if there's any type of erosion, like rainwater or a broken sewer line or any of those type of things, it'll actually mitigate any type of erosion. You can imagine when you have sand, it washes away very easily. With that equipment, they're mixing with water the specific grout for this application, and it's running through this pipe, and it's highly pressurized. And that's what they basically are doing. They'll drill some holes first, and then they'll go ahead and shoot that grout in. And they're going to go up to 8 feet deep with the grout balls. The grout balls typically expand about 2-3 foot. So there'll be a series of balls that will expand underneath the building. It's over 100 years old, and it's on brick. So originally when they built this, the brick masons would have excavated the area for the foundation, and then just went ahead and put their brick and their mortar down. There wasn't a lot of forethought about soil types back then. Over here, this brick here has been cut, and the old wall line used to go all the way across here, and these weren't garages because a lot of people didn't have cars back then. You can see the old brick, and then you see concrete below it. Now originally this building was constructed, the foundation was just brick. The 1920s and 30s, when the automobile became more mainstream and people could afford cars, that's when you saw a lot of dig outs for garages. So what they did is they actually poured the concrete underneath the old foundation. They probably did it in sections, or there's some way to retain this foundation to do this work. And you can, and further evidence of that would be the concrete retaining walls here. That added a weakness to the building by taking away the wall, the brick foundation, and the wall above it. It created a large opening where the building is potentially vulnerable for a earthquake. So what we've done in this particular case, we put a steel frame, and this is a moment frame. If you don't know what these are, what these are designed to do is take the load. So when we have a big shaker, it's anchored into the ground. So we have a continuous, we call this a concrete grade beam, and we attach it to the floor. And if you can get a shot of that, it keeps the floor from shifting around. So when you have a big shaker, what will happen is that floor is going to want to shift around, and then these steel columns are going to take up that seismic load. And then here we have some shear wall. So this is where we actually added this wall to add strength in this direction. So the shear walls, anytime you see a shear wall, you're looking at how it's going to strengthen the building. This is a compliant retrofit. It should be noted that even though this is not a 5-unit building and not on the soft story list, we still comply with the current mandate. What that does, it's a higher standard of retrofitting, you know, because what we see a lot of as we see contractors go out and put a little shear wall and bolting in and then tell the owners that their building's been retrofitted. This is obviously not a good thing, because you need to have an engineer analyze the building and see where its weaknesses are. So in this particular case, we put the frame in and it added the shear walls. So there was a substantial excavation, concrete work, shear walls. This particular job's getting wrapped up, and we'll be checking in on the next job with you guys.